Okay. Whenever you're ready, Coach.
Oh, okay. Sorry. No, I was actually just telling Donnie to get on.
Oh, okay. We'll see. We'll see about that.
Yeah. Get to class done. All right. Let's see if he gets on. All right. Basically, what's going on is I'm kind of taking over next week for Mrs. Dolmaj. Obviously, she's having a child. So she's going out on pregnancy leave, and I'm taking over for her. Now she's got everything planned out. So whatever she ends up on, stopping with today, I'll pick up on Monday. So it'll be pretty seamless, we think. So there shouldn't be any hiccups in class or anything. I've had most of you guys. I looked down the roster. I think I've had everybody except for the kids that have transferred in. Before. So like I'm used to, having you guys anyways, but it should be pretty seamless. We'll just pick up where you guys leave off today and go from there. All right. Anybody got any questions? All right. Sounds good. I appreciate it.
Thank you. I do want to just add in that we are going to have 4 seniors joining us from my regular pre-calc class because they're also doing the algebra boot camp as well. So they will be joining us. Well, they'll be joining you guys starting Monday. So you'll have 4 other seniors in class. Not that really affects you any at all. And he's still going to do the participation the same for you guys. And Coach Padrone is going to send you an email out by the end of the week with all the links to his Zoom link, since you won't be joining mine anymore.
Zoom
and his YouTube.
Yeah, YouTube as well. Yeah, for sure.
Mm-hmm.
So what I'll do is what I did with my other 2 classes, my Algebra 1 and my Algebra 2s, is I just create playlists. So you just, I'm sure you guys have seen it. Like I think all the other teachers do the same thing too, probably. But there'll be a playlist for you guys, and you just, if you miss class, just log on, look at the playlist, pull the class up, and then you're good to go. All right. But it'll be specified for you guys. Good.
Thank you so much.
Thank you. Y'all have a good one. Take the flag, Jacob. Hopefully Dunny shows up. See y'all.
We'll see.
All right.
Take care.
You too.
All right. Any questions, guys? Okay.
Wait, I was kind of confused. Wait, so what's happening? I was zoned out.
That's okay. I feel you. I do that every morning at our faculty meeting. Coach Padrone is covering for me starting Monday.
Oh, okay.
So he'll send you, really it's going to be seamless. There'll just be 4 new kids joining the class. Who is it? Bennett, Lloyd, Blake Dugan, Richie Smith, and Drew Fellhauer are going to join. I haven't told them yet, so I'm just telling you guys because I don't see them till E-period tomorrow. But they're able to join since they have like art during this time. And I'm doing the same thing with them to prepare everyone for college math. Anyway, so they'll join you. And the only different thing is that you guys just have to log in through Coach Padrone's Zoom link at the same time. So he'll email you that info. Cool?
Cool.
Okay, awesome. All right, so just as a reminder, your last class with me is today. The last graded assignment is, I guess, technically the quiz that's due by, tomorrow, right? Yeah, tomorrow at 3:15. I know some of you have already turned it in, which is great. We're just gonna do some review today. So you'll have 2 more grades with me. That's today's participation grade and then the quiz. Once I'm done teaching you, there's no like makeup grades. I'm not really talking to any of you where that matters, so it doesn't really matter for any of you because your grades are all good. All right, we'll just do a brief quiz review today, which should help you with the quiz. All right. If you haven't looked at it already, the quiz is over topics 6 through 8. Topic 6, 7, and 8. Topic 6 is factoring. Topic 7 was solving quadratics by factoring. Topic 8 is solving quadratics using the quadratic formula. So they're all about quadratics today. And some quadratics, you can factor. For every single quadratic, you can use the quadratic formula. It will always work. And for a couple, you can use both. So that's what we're going to look at today. The first part I want to focus on is just factoring. And reviewing factoring. Okay, so a couple of the main things with factoring. Your first step to factor is factoring out the GCF if there is one. It's always your first step. We created a factor tree. I'm not going to recreate that entire thing, but you do have it for good reference. And first step's always a GCF. If there is one, you need to factor it out. The second main thing is probably the one that students struggle with the most, which is just difference of squares. So I wanted to give an example of difference of squares. These are just the two main things, again, that students struggle with the most is GCF and difference of squares. So I want you guys to each come up with your own example of difference of squares real quick. All right, so my example of difference of squares looks like this. Yours could look really like anything so long as it is a difference, right? Subtraction of two perfect squares. The way that it factors is we take the square root of each, 1 plus 1 minus, right? This works out. If we multiplied through, we would get back to where we started. Okay. I want to get into some examples of factoring next. So for all of these, I actually have 4 examples for us. We want to factor each one completely. So I'm going to write a couple on the screen and give you guys some time to just practice them. And then I'm just going to go through them without a huge explanation since it's more review. So think of this as kind of like board work. Jacob, did you hear back from anybody?
No.
Thanks for trying.
Yeah. I'm surprised Matthew's not on here.
I know, me too. All right, those are our first 3 that we'll do first. So you guys try those. Use your factor tree if it's helpful to go step by step and factor as completely as you can. Remember, your first step's always a GCF if there is one. Okay, so these three have been factored completely. Number one had a GCF of 3, so we could factor that out. What remained was a quadratic trinomial. It was factorable. A was 1, so we did not need to utilize the box method, although you still could. Two numbers that multiplied to a times c, right? 1 times -2. So two numbers that multiply to -2 add up to -1 are the -2 and the +1. So we can go right into those factors there without utilizing the box method since a was 1. From that point, we are all done. Number 2 did not have a greatest common factor, but it was a difference of squares. So we used our difference of squares method, and then we were done. Number 3 had a GCF of 5x. What remained was a binomial. It was not a difference of squares, so we are done at that point. Any questions on the first 3? Okay, same, let's do the last one here. Just requires a little more work. So same directions to factor completely. All right, try that one. Okay, so we don't have a GCF here. And so we see that we do have a quadratic trinomial where a is greater than 1, it's 6. So we need to use the box method. And we'll multiply a times c, right? 6 times 5 and get 30. So we need two numbers that multiply to 30 that add up to 13, and they are 10 and 3. So we'll get our factors using the box method. And then remember what goes in here: first term, last term. And then we break apart that 13x with the 10x and the 3x that we came up with. And they can go in either order. You'll still get the same answer at the end, but your box might look a little bit different. Okay, then we take out the greatest common factor of each column and each row. And in this case, everything's positive, so everything remains positive. Going across the top row, we'll take out a 2x, and we can factor out just a 1 there from 3x and 5. So we're left with 3x plus 5 and 2x plus 1. You could multiply that out and see that when you do FOIL it out, it will get you back to where you started from. Okay, that was our review of just factoring. We're not solving anything yet, right? Solving means it implies that we have to find an answer, and that means we need an equal sign. We don't have those here. These are just expressions, so we're just factoring them. When you have an equal sign, that means you have to solve. So this next part 2 of our review, will be solving the quadratics. We can use factoring or the quadratic formula. There's obviously other methods we can use to solve quadratics that we have not gone over, like completing the square or graphing. You'll do graphing next week. So again, quadratics make parabolas, right? And the most amount of times a parabola can go through the x-axis is 2 times. So that's why at most we're going to have 2 solutions to these. Also because it's x squared, so we'll have 2 solutions. Okay, so again, the methods we learned are factoring and quadratic formula. Factoring you can only use, obviously, if it's factorable. Quadratic formula can always work. So what we're going to do is solve a couple using both methods. And QF will be quadratic formula. All right, I'm not going to rewrite the quadratic formula. I only have so much room on this whiteboard screen, but be sure that you know it. You can just look it up or it's in your notes. So the first example will definitely be, well, these will both be factorable since we need to solve them using both methods. So the first one, we have 10x squared minus 7x equals 0. So we will solve this using factoring first and then quadratic formula second. All right, so I want you guys to factor this one first. It's set equal to 0 already, so it is ready to be factored or quadratic formulaed. Okay, we can factor out the GCF of x, and we'll be left with 10x minus 7 equals 0. From this point, we have two factors, right? We have the greatest common factor, that is x, and then we have that binomial factor that remains, that is not a difference of squares. It can't be broken down any further. So each one of these factors has a variable in it, so they're going to provide us each a solution. So our first factor is 0, so we set it to 0. That's a solution. Our second factor, 10x minus 7, we'll set to 0. Again, setting to 0 because we want to know where it hits the x-axis. That's when y is 0. When we solve, we'll add 7 and divide by 10 to get our second solution of 0.7, right? 7/10. So we should get those same two solutions when we utilize the quadratic formula. Now, we don't necessarily have an a, b, and c that we can see. But as long as you have an a value, you're good. B or C can be 0. So A here in this case, part B. A in this case is 10. B is -7, and we do not have a C at the end, so C is just 0. So we can still use the quadratic formula when B or C is 0. So the opposite of B, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we can see that what's under the root ends up just being 49, which is nice because this goes away, multiplied by 0. So we're left with 7 plus or minus root 49, which is 7, all over 20. These are rational answers, right? There's no roots in them. So we can go further and get our actual two like fractions or whole number answers here. So 7 plus 7, 14/20ths, which we can divide by 2 to get that first answer of 7/10. And then we'll use the minus 7 minus 7, 0. 0 over any non-zero number is just 0. So those are our two solutions. Again, we should have gotten the same two. It's the same equation. So we can use both methods to solve there. Okay, I want to go into one that does not have like rational answers here. So let's solve using either method. So some can just be your choice, or you might have to determine, hey, I can't factor this, I have to utilize the quadratic formula. Let's try. That one here. So let's get it set equal to 0 and see which method we can use to solve it. Okay, when we set this to 0, we'll have x squared and we add the 10x, so plus 10x plus 10 equals 0. And it's a quadratic trinomial. It's not factorable though, right? There are not two numbers that multiply to 10 that add up to 10. So we have to utilize the quadratic formula. So A is 1, B is 10, and C is also 10. So when we put this in the quadratic formula, we'll have the opposite of B, plus or minus 10 squared, so 100, minus 4 times A is 1 and C is 10, all over 2 times A, which is 1. That's going to equal, our discriminant will be 100 minus 40, so our discriminant will be 60 under the root, all over 2. Now we learned the other day how to break down roots, right? So the square root of 60, the biggest perfect square that is a factor of 60 is actually 4. So we can break down the square root of 60, which I'll do in the next step, as root 4 root 15, since 4 times 15 is 60, all over 2. Then we can cross this guy out and bring it out. So we'll be left with negative 10 plus or minus 2 root 15 all over 2. We can then triangle simplify, right? We can't simplify what's under the root, but we can simplify if these three are simplifiable. We can divide, in this case, all by 2. So when we do that, we'll be left with negative 5 plus or minus, we have a 1 there, which we don't need to write. And we don't need to write the 1 in the denominator either. So there we go. Now that one again was not factorable, so we did have to utilize the quadratic formula. Your quiz isn't too bad. It looks very similar to what we just reviewed today. That's really all I have for you. But as a quick reminder, that quiz will be the last graded assessment or assignment for you guys with me. If you have anything that you have questions on, please make sure that you ask me. You can stay on. I'll be on for a few minutes, or you can come to the Zoom office hours at 2 o'clock. But be sure that you upload that quiz by tomorrow at 3:15 if you haven't done so already. And I wanted to thank you guys for a good year, and good luck in college or senior year, wherever you're going. So yeah, if you need anything, just reach out, okay?
Thank you.
Thank
You're
you.
welcome, Jacob. You're welcome, guys.
Thank you.
You're welcome.
It was a fun year, Ms. Domas.
It was, I know.
Thank you.
You're welcome. Good luck, Josiah.